Needed to do that. So, hi guys, welcome back to my channel. Good to see you again. In this video, we are going to talk about ASR training data creation. As you know, like this is part of my ASR playlist, and yeah, so in this video, we are going to create a training data set for our version 2 of ASR. So, right now, what we have our ASR model as version 1. uh, what it does is like as if you give it any speech or audio file, it will convert into text. That's what the job of ASR is. But why I call it version one is because I am like first of all, like in this video, what is going to be the scope of the video? The training data set creation. We are Let me explain you the problem statement, like why we are doing it. So if you have given an audio file, right? So it like how I'm speaking right now, I'm speaking, but there are some audio events, what we call it as audio events, like if someone laugh, right, if someone sneeze, if someone sniff or cough or something like that, or the most basic audio event is pause. So if I am talking like this, taking pause, so that must also be identified by ASR, that a person is like taking uh, pauses, longer pauses, something like that. So that's what the focus area for this video will be, and specifically on the training dataset creation for this use case. Uh, like uh, so, Now let's talk about the implementation part. How am I preparing the dataset? For the dataset, I have some audio files, as you can see. Like this is just a sample dataset, not like complete dataset. I am for, but yeah, I have some sample audio files, and now what? Again, like assuming that, but it's not that. I just have these data. Like I have like very much data, and very much data is available online as well. Like so, I'm not like yeah. Saying anything about it, like the and even like we can talk about some of the data set which is open source and very much in terms of like you can either buy a high quality data set online, like there are many portals you can search about it. But if I would want to give my suggestion for data set, if you like if that like that can become a blocker in the initial phases of training. So I would say that you can refer to something called so something like OpenSLR dataset or any other dataset like from Hugging Face, or there are many datasets there. So that's about it for dataset. But assuming that I have a like very large dataset, how am I going to solve this problem of adding events like pause to my ASR model? So I'm going to create a tag for that. So if you can see, I'll show you over here. The tag which I'm using for pause is just this, like angular brackets and in between pause. So and like that's, if I can also show you like the current sample output data set, like after the training, not after training, but after the data set creation phase. This is how your data set should look like. It will have this tag like pause in between your text, which means that user has taken pause between saying this and this. So that's what the focus area is, to create this data set from the current data set normally provided online, is like this kind of a data set, which you will get like audio ID and like audio file and the text of the audio file. That's it, like the data set you get for training the ASR, right? Okay, cool. So let's move to the implementation. I talked about the data set that is absolutely prerequisite that we need. We don't even need transcript right now, like for my use case, because I have the ASR model and I can get the transcript for the speech from there. Now, considering that I'm not like boasting about my accuracy of my ASR model, but I'm just saying that I'm not even this training is not for even improving accuracy at all. This training is just for adding the events, audio events like pause. Cool. So Yeah, so that ASR would automatically not give transcript like this, but would actually give transcript like this automatically without doing any processing once you get the transcript. Okay, cool. So that's what I'm telling you, that this is not regarding improving accuracy. That's why we are not trying to use the best ASR mechanism or the data set which is yeah, very accurate in terms of word prediction. So we are not focusing on word prediction. That's why I'm saying that we can use my current model. That's what I'm going to use, uh, because the scope of concern is to add events, not to improve word accuracy. If I had to word improve word accuracy, I have to uh, get the answer. Like, I can't rely on accuracy of my current version one model. uh, yeah, like I need best of the best accuracy in terms of word, uh, yeah, word prediction, uh, when it comes upon improving ASR model in that regard. And right now, let's just move forward. So now we need to do processing to add these tags into the data set to create data set from this to this. We need to do some processing, and that's the processing is the file which I've opened it for you. And let me show you what I'm doing over here. So before moving there, I would like to show, yeah, like I already showed you that what is the current ASR like performance on some the sample audio files which I have taken. So exactly, like so that's why, like, I'm saying that I don't need to worry about any external ASR for this, especially this training purpose, because we are just adding events and like especially pause event. And I have audio files, so you just need audio files. That's why I said it, you don't even need transcript because you can get it from the ASR which I already built, like yeah. And now what else? So next thing is, I think, yeah, we can jump into the steps of this pre-processing, which converts your data set to the required format for training. So quickly, step one will be okay. So first step will be to set up the wired model. Now in this video, I can't explain you the exact details about wired, what is voice activity detection, but to give a crisp idea about voice activity detection would be, if you have an audio file which is duration doesn't matter, like 10 minutes, 20 minutes, or even 2 hour, whatever audio file you have, you give it to VAD model. And what it does is that it gives you timestamp or time range for speech instance in that audio file. That's what it does. Like I have this audio file, and it has something like this spoken, and yeah, this is the audio file, and this is the transcript for that. But what a VAD model does is just to break the audio file into multiple smaller files, such that each, and then like into, you can say, a linear order, that it breaks it like that. If I could show you that, if this is your audio, right? So audio is equal to this. So what WAD does, it creates array first of all of something like if I just put it, yeah, if it, like, audio in terms of binary string, like, doesn't look like this, but imagine if it is binary string. So it gives you like this and this. So it actually doesn't give you like the cutted audio format, but that's what you can get using VAD. Like, you don't need anything else. If you have this audio file and if you have VAD model, you can convert it to this. But what VAD actually gives you is not this. Like, this is the actually end output what we want. But like, how can I just put it to the next line? And yeah, so I'm just remove. So okay, cool. So this is the output what we want. And what VAD gives you is, again, it gives you array first of all, array of dictionaries where they have a start. Oh no. And you have end. So and could be like I don't know, 0.6, start could be 0.11139, whatever. So and similarly, like, next start would be a bit greater than 0.6, maybe 0.67. to 0. I don't know, like what 1.2, like that's it. I think it's fine. So cool. That gives you the timestamp of the voice activity. That's what it does. As simple as that. Timestamp of the voice activity. That there is some audio, some speech in between this time and in between this time. So that essentially means that between 0.6 and 0.67 there is some kind of a silence, some kind of a gap. You can tag it as pause. That's what we are going to do. And yeah, so it's like actually that. And so we have the VAD setup right here. And if you want to see, these are the parameters which goes in. I'm not going into detail of these parameters, you can search about it. But okay, so the VAD model I'm using is Celery VAD. And like I can explain you in simple terms that minimum speech duration is that each segment must have like this much length of this much duration of speech. 180 is in milliseconds. Okay, cool. As you can see in the parameter name as well, uh, millisecond. And this is important. Minimum silence duration is that at least 0.60 millisecond silence. Or how does it translate to seconds? It translates to zero point 0.6 or 0.06, I think. 0.6 seconds of silence will be considered as a silence in voice activity. So yeah, because sometimes, and there is padding also, so you don't have to worry much about that. So padding is also millisecond, so it will like just add up over here somehow, that your duration should be this plus 36 millisecond more. Okay, so it would be around, you can think it as like I don't know, 72 millisecond would turn out to be 0.72 0.72 or something like that. So you can imagine like I'm trading about point 0.7, point 0.8, not point 0.7, 0.07 or 0.08, which closes to around zero point 0.1 second of silence. So that's like what I'm trying to show over here, that how actually the segments are getting separated. So these are the parameters which I'm not going to detail about this threshold parameter. Like it is some kind of like yeah, probabilistic thing. But you can just search it out online about Celery ad and these parameters. Yeah, that's like basic stuff in terms of what like knowledge you should know about it. Like you can Google it and it will be really easy to understand. And now let's come to the next part. We have step one is done. We have bad setup. Second is like we should also have our inference setup. So this is my inference model, which is basically running in another service. This and like this is the payload for like the API endpoint. I have like basically uh, yeah, given for that transcription model. And that's what it does, like just hit that server and get the transcription. So step one is that I think these are the requirements. Step two is actually when we use these two things like the WAD to get the separated audio files and to get them inference and to get the actual text out of them, right? So this is also audio in terms of byte data. We at the end want audio in terms of text to data. Sorry, output in terms of text to data, or you can say output of audio data, right? So I put it like that, something like that. Okay, cool. So yeah, that's what I want in the end. And right now we just have a single audio file. So step one is to do WAD, like like yeah, so let's get into that first of all. So I've told you the basic setup for WAD, and now we are moving to the part where we will just give audio to the WAD model for identify segments. So this is a basic script. Basically just goes and read on to the data set which I have already, like the sample which I have already right now. And for each audio file we convert that into byte format, like using simple like read operation. And I have the audios over here as well, like in the folder I have mp3 files. So that's it. Read it and pass it to the WAD, because it takes into the mp3 like byte data format. So cool. Now we get the result from WAD. It will look probably like as I told you, like I can just copy paste over here. That will be easier thing. yeah, it would look like something like that. And for each of the segment in the WAD result, I'm going to see the start, end, and basically just get the transcription done for this segment. How am I going to do that? So first of all, we need to cut that audio file. So yeah, this is the second part. After the second part was like implementation, and the third important part is the cutting the audio file. Like cutting, what I mean by is the trim the audio file and get the actual audio speech between the start and end of this WAD segment which we got. So that's like I can show you the code for that. It is really simple using the audio segment library, which like pied up audio segment class from pied up library, very popular in terms of voice processing in Python, I think. And yeah, so that's it. Like that's what we are doing over here, getting the audio file start, and in this, like once you load your audio into audio segment, and you can just trim it like as simple as that, and then just export it to your required file, and that's it. Now you have the trimmed version of the segment which you wanted. Now you need that between two segments there is pause. So you just create your like first of all you have to get inference after on this file, and on the segment, on the smaller segment, right? So once you get inference, you just create your final text by adding the inference, and in between adding the pause tag, which is this I already told you before. Yeah, that's about it. So the third step was to get the time range and to cut the trim the audio file, and the fourth step was to get the smaller file, get it, and then pass to inference server, get the transcription, and like yeah, adding. So if I could like break it down to the steps over here, so like the first step was our basic setup for AS WAD model, and like inference server I hope you will have ready for yourself or whatever model which you are using. You can get from there. Step two was to get actually start the implementation, like in terms of yeah, here step two starts to like read the file and get WAD. That's it. And for step, this is where the step three starts. That for each of the WAD detected segment, I'm going to get the trimmed audio version. So this is, you can say, step 3.1, and then this is 3.2 where you actually get the text for the trimmed audio version, trimmed audio, and then the like last thing is to create your final text, and then storing it in terms of like array or somewhere where you can actually convert it to data frame later. Yeah, that's it. Like data frame, we started from a data frame which looks like this. Audio is there, text is, transcription is there, pause is not there, and we got something like that where audio is there, textual uh, words, transcription is there, and even audio event called pause is also there. That's it. Thank you guys for taking out time for this video, and yeah, so that was all about it. Thank you. Thanks for watching. See you. Have a good day. Bye. We are ready to initiate the training, and we will soon upload the video of the training. And after that, the result of the ASR model. I'm like really excited to share that all with you. Cool. So goodbye. Take care. Good night.